In this example, they're asking for y equals x cubed. And this is going to be possibly, well, it will be different to y equals x squared that we did before. And we'll see why when we try to draw our grid. So in the same way as before, we'll draw the grid out and we'll do it from -3 to 3 again. And this time, when we cube these numbers, remember, if you to do this in the calculator, you would put your brackets in there, -3 cubed. If you were to do that, you'll see that it's going to be a negative number. The reason being that it's -3 times -3 times -3. And this bit here becomes 9. But then 9 times -3 is going to give you -27. And that's what this number here would be. So in the same way, this would be -8. This would be -1, 0, 1, 8, and 27. And you see here now it's still got that sort of symmetry that we had before, but in this case they're negative. So if we were to draw that, it would look something like this. So we've got the coordinate 1, 1 here, the coordinate 2, 8 here, and the coordinate 3, 27 all the way up here. And do you see it very quickly goes much higher than it did in the x squared. So in this case, it's a mirror image, but it's sort of rotated even. If you imagine that this part of the graph here has not been reflected over the axis like it was in the x squared, but in this case, it's sort of rotated. So you can rotate this all the way around 180 degrees, and it will look a bit like this. So this, if we were to scroll up, describe the symmetry of the curve. Well, we would say that it's symmetrical, but it has a rotational symmetry. It's rotationally symmetrical, I guess. Symmetrical of order 2. Now, if this order 2 doesn't ring any bells, have a look at the rotational symmetry videos that I've done earlier. But remember that this isn't all the information we need to write. Just one more thing here. At what point are we spinning it around? So it needs to be about the point that it spins, which in this case is the origin. So this would be describing the symmetry of the curve. It's rotationally symmetrical of order 2 about the origin being here. Okay, in example 2, it's asked us to draw a graph with this equation. And by doing this, the x and y grid that we did before, I've skipped this stage out because we've just generated these coordinates. So that will have the coordinate 0, 0, it will have the coordinate 1, -2, and then it will have 2, 2, and 3, 18. And we'll see that if we join all this up, it'll look a bit like this. Anything with an x cubed in it, you'll notice will go down on one side, do something in the middle, and then go up again. It could do this, or it could do the other way around. It could come in from the top, do something like that, and then go back down again. And generally, it will follow this shape. Sometimes in the middle here, it'll be just a smooth curve like this. Sometimes in the middle, it will do that thing. So we'll see by drawing a few of these that we'll get different varieties, but x cubed always has that coming in from one direction and going back out from a different direction. Okay, so what about in example 3 then? Draw the curve with the equation. Oh, now this is different. This is not cubic anymore. This is what's called a reciprocal. And reciprocal function has something divided by x, and this could be written as y equals 8x to the -1. And if you've forgotten where that comes from, you should watch the videos on indices, where it shows that 1 over x could be written as x to the -1. Either way, if we try to draw the curve with this equation, we would do the same thing. We would draw the grid with the x and y between certain values, between -3 and 3 normally, and we would plot some points and generate this curve. But the thing is, if we were to do the 0 coordinate, then we would be doing 8 divided by 0, which gives you a math error on the calculator, which is infinite. And that can't be drawn very easily on a graph. So what you have to do at this point, if you're to draw the x-axis, on the line x equals 0, it's an asymptote. It's a point where the graph is undefined, and that's shown with a dotted line. So that would be at the point where x is 0, which is in fact the same as the y-axis. And this is spelled asymptote, A-S-Y-M-P-T-O-T-E. It's an asymptote, and that's the point where the graph never crosses, and it just gets closer and closer to that value. And we can see that over here on the computer-generated version of that it comes in from one side and it goes down this way, and then it appears on the other side like that. And this is what the graph 8 over x looks like. And it's asked then on the same diagram to draw the line with the equation y equals x plus 2. And that's this straight line here that goes through at 2 and has a gradient of 1. And it says write down the coordinates of the points where the line crosses the curve. And that's going to be one point here and the other point here. So the first coordinate will be 2, 4, and the second coordinate will be -4, -2. So these are the two coordinates that where the two lines cross, and in fact this is where you would say that 8 over x would equal x plus 2. So this is where the two graphs equal each other, or where the two functions equal each other at these points. But the values that you'd be looking for to solve this would just be the x coordinates, which would be 2 and -4. Okay, have a go at the exercises.